trig days, what does an inverse do? That's kind of making the college ask the question. What's an inverse do? It like flips x and y. So if I said sine inverse of 1/2, that means tell me the angle when sine equals 1/2. But if you remember when we did these in trig, we talked about if it's a function, you can only have one possible answer. So when we talked about the inverses, we had to limit them to certain quadrants. It didn't exist in every quadrant. I am going to keep things fairly simple in here because I don't want to spend a lot of time going back to trig. So we're going to pretty much only deal with positives, so like first quadrant type questions when we solve these. So on this, if I wanted to do this derivative but I didn't remember or have the formula for sine inverse in front of me, I could rewrite it. If you wanted to move sine inverse to the other side, then it becomes regular sine. So that means the sine of y is equal to x. And after yesterday, we know how to do the derivative of this. Derivative of sine is cosine, angle stays the same, times derivative of the inside. What is the derivative of y? And the derivative of x? So dy dx is 1 over the cosine of y. But let's say I needed this in terms of x. If I didn't want that y left in here. If we think about a triangle, sine of y equals x. That means when my angle is y, sine is opposite over hypotenuse. So my opposite side would be x, my hypotenuse would be 1. How could you find that third side? Excuse me. So a squared plus x squared equals 1 squared. Square root. Normally we would do plus and minus, but we are only going to deal with the first quadrant. So that missing side is the square root of 1 minus x squared. So we could simplify. Cosine of y, I can look at this triangle and I can tell you what cosine of y is. Cosine is adjacent over hypotenuse. So it'd be the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. So on these inverse functions, I am going to ask that the final answer be in terms of x, not in terms of y. So we will have to draw that triangle in order to do so. Questions? So how would we write this? Y equals x. Derivative of tangent is secant squared. Angle stays the same. Times the derivative of the angle. Derivative of y is dy dx. Equals, what's the derivative of x? Just 1. So dy dx is 1 over secant squared y. But if I want this in terms of x, what do we have to do? Well, we know from angle y, tangent is x, or x over 1. Tangent is opposite over adjacent. So 1 squared plus x squared equals c squared. So my missing side is the square root of 1 plus x squared. Okay, what's secant? We think about SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse, so this would be hypotenuse over adjacent. So it would be the square root of 1 plus x squared over 1. Since it's secant squared, if I squared each of these, what do we get?
1 plus x squared.
Because the square root would drop the square, and the denominator is only 1, so we could drop that. Questions? So these derivatives are a little bit different. We have y equals 1 over sine inverse of x. Couple ways we could do this one. Any thoughts? Okay. So what is 1 over sine inverse? Okay. That negative 1 is representing the inverse though, so I can't just bring it up to the top and make it a positive 1 power. This is like saying you have sine inverse of x to the negative 1 power. So if you did your derivative, the negative 1 would come down, inside stays the same, subtract 1 from the power, times the derivative of the inside. The derivative of sine inverse of x, don't we know that from the first example? So the derivative of sine inverse is 1 over the square root of 1 minus x squared. So instead of reworking that, I'm just using our earlier example. Okay. Is there anything we can do to clean this up? Okay, so the negative 1 is just like a coefficient. Since this is to a -2 power, you could drop it down to the bottom to a +2. But that's really all we can do. It's just ugly. There's really no cleaning it up and turning it into something pretty. I know that one got a little bit ugly. Questions there. Remember, f of x is the same thing as saying y. Arctan is just another way of writing tangent inverse of square root of x, so that's like x to the 1/2 power. So if I did this derivative, you have x times tangent inverse of x. So the derivative of x is 1 times the second plus the first times the derivative of the second. Okay, the derivative of tangent inverse. We used this, or we found that in the previous example. It's 1/1 plus x squared. That was the formula that I gave you way back when. We just kind of are deriving these formulas now and using them. So derivative of tangent inverse is 1/1 plus x squared. But your x is your angle, and for us, that was x to the 1/2. Since it's not just a plain x, what would I have to do? Chain rule, right? Times derivative of the inside. So the derivative of x to the 1/2 is 1/2 x to the -1/2. We have a 1/2. X to the first times x to the -1/2. You add those exponents, so that's x to the +1/2. X to the 1/2 squared is just an x. You could clean that up a little bit more, but you could leave it like that fine as well. That would be fine. So what I've done, the first two examples, I actually proved a couple of the formulas for derivatives of inverse trig functions. I need you to open your book up to page 214. If you look at the bottom of page 214, it has a box with all of the derivatives of the inverse functions. Sine and tangent, we proved those. Cosine, I think it's going to ask you to prove on one of your homework questions, so we can get that as well. You will not have to memorize these on a test. I'm not going to make you prove them. So if I needed you to do something with these, I would give you those formulas on the test or quiz. Some of your homework questions will ask you, kind of like we did on the last two, to do some derivatives with these inverse functions, but you can use these formulas as fact. So for instance, if I asked you to do, I don't know, let's say I gave you to do the derivative of this. Okay, I can realize this is like saying x squared minus 1 to the 1/2 power times secant inverse of x. So what rule will I have to use to do my derivative? Well, you're going to need the product rule and the chain rule. So the derivative of the first, the 1/2 comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside, which is a 2x, times the second, plus the first, times the derivative of the second. You do not have to prove to me what the derivative of secant inverse of x is. You can look at your formula. So on page 214, I look, derivative of secant inverse of x is 1 over x times the square root of x squared minus 1. Right, so then all we have to do is clean this up as much as possible. 1/2 times 2 cancels. You can leave this as x squared minus 1 to the negative 1/2. You could realize a negative would put it on the bottom. Either way is fine with me. Here, if you have an x squared plus minus 1 to the 1/2 on top and on the bottom, what happens with those? Cancel. And so we just get a 1 over x there. Okay, so you can just use those formulas as fact. You do not have to memorize them on a test or quiz. You will not have to prove them. We just get to accept those things. I showed you where a couple of them came from, and I think you're going to prove one more. Okay, that's all the new content. Do we need to do any review problems? Are we struggling with any of this stuff, or do we want some generic problems? Do we want a couple? Maybe 1 or 2. We did one problem yesterday with the second derivative, so why don't we do another? Make sure we're okay with that. So first of all, when I see the cube root of x, I would write that as x to the 1/3 power. So, working through here, exponent comes down, inside stays the same, subtract 1 from the power. Do the same thing with my y's. The 1/3 comes down, y to the negative 2/3. But every time I do the derivative of a y, we have to put dy dx. And derivative of 12 is 0. What do you want to do now? let me ask you some questions about cleaning this up. What is negative 1/3 divided by positive 1/3? Negative 1. Both of these have negative exponents. What do negative exponents do? Flip it. So the y would be on top. And the x would be on the bottom. So that is the simplified version, as clean as we can get it anyway. All right. I asked for the second derivative then. So if I do the derivative of this, notation, you can call it y double prime, or it's d squared y over dx squared. What rule would we have to do? Quotient rule. So that's low, d high, subtract 1 from the power, derivative of the inside, minus high, d low, over low squared, x to the 2/3 squared, so 2/3 times 2 is 4/3. Do we want to leave it like that? No, this is a mess. So let's see what we can do to make it better. We have negative 2/3 x to the 2/3. Y to the negative 1/3. And in place of that dy dx, I'm going to put what dy dx is equal to. So negative y to the 2/3 over x to the 2/3. Minus negative would make plus 2/3 y to the 2/3 x to the negative 1/3. So, still in the process of cleaning this up. Do we like to leave a fraction in a fraction? So one thing we could do, since both of these have a 2/3 in them, let's just take top and bottom times a 3. So that would give me a negative 2 x to the 2/3. But, actually let's go ahead and simplify that. If you have x to the 2/3 on top and bottom, those things cancel. We have a negative times a negative, so it will become positive. With my y's, we add exponents. So negative 1/3 plus 2/3 is positive 1/3. Okay, we have 2/3, but times 3 would just be a 2. Looking much better. Anything else that we should do? Not necessarily. You could leave it like this. If you wanted to get rid of that exponent, that negative exponent on the top, we could take everything times x to the 1/3. Again, this is just to kind of clean it up even more. So it would be a 2 x to the 1/3, y to the 1/3, plus 2 y to the 2/3. Those x's would cancel. And the bottom would be 3x to the 5/3. And again, that's just to get the negative exponent off the top. It looks a little bit nicer. What I want to do I know some of these problems are long. We've been adding a few each day, so we've had several days on this assignment. You are now ready for everything. So I think yesterday I gave you a chunk of them. So the ones that we have not had yet were 17, 49. I'm not sure I actually want you to do all these, so I'm going to take off a couple. Let's do 51. And 63.